Let's talk about decimal division and strategies for estimating and for doing mental computations. I'm going to assume that you're already proficient at whole number mental division. Our first strategy is to think of our decimal numbers as money and answer the question, how many groups? So here, we could think of our 25 hundredths as 25 cents or quarters. So my question is, how many quarters, how many groups, how many quarters are in $3.75? Well, there's 4 quarters in $1, and then I have $3, so that'll be 12 quarters, and then 75 cents, that's just 3 quarters, so 12 plus 3 is going to be 15 quarters and $3.75. We can also use this for estimation when we don't have as friendly numbers. So here, I don't have any quick facts in my head about $3.50, but I can think about it in this way. If I have $14.26 in my wallet, and there's some item that costs $3.50, how many of those items can I buy and still have enough money to pay for them? Well, one item will be $3.50. A second one will get me up to $7. And then if I double 7, $14, so that would be 4 items at $3.50 a piece will be $14. So I'm going to say this is about 4. If I check it on my calculator, the exact answer is somewhere around 4.07. So that was pretty good, thinking about how many items that cost $3.50 can I buy for $14.26. It got me pretty close. Next, I'm going to think about my decimal numbers as fractions. So there's some decimals that I associate with fractions really easily. So for example, 25 hundredths, 0.25, I know is 1/4. So if I take 9 1/10 divided by 25 hundredths, well, if I'm dividing by 1/4, I can multiply by the reciprocal, that's times 4. 9.1 times 4 is going to be 9 times 4 is 36. 0.1 times 4 is going to be 0.4, so 36.4. All I did in my head here was that I made this divided by 1/4, which is times 4, and then I separated this out, 9 times 4 and 1/10 times 4. Down here, I know 35 hundredths is 35 over 100, but to make it easier on myself, I might think of this as about 0.33, and I know that 0.33 repeating is 1/3. So now I can take 12 and 21 hundredths divided by 1/3 is the same as multiplied by 3 over 1, or just multiplied by 3. 12.21 times 3, 12 times 3 is 36. 0.21 times 3 is 63. Oops, we'll make this an approximate. And so I have an approximate value for 12 and 21 hundredths divided by 35 hundredths. If I check this on my calculator, I can see that the answer comes out to be in the ballpark, right? That wasn't too far off, 34.8 and some more decimals there. Our next strategy is to move the decimal place the same number of places to the right in both numbers. So my brain has a harder time thinking about 8.6 divided by 0.2, but if I switch it to whole numbers, then I have an easier time. So if I were to move the decimal to the right one in each case, this would be 86 divided by 2. Okay, half of 86 is 43. Why does this work? Well, I can write 8 6/10 divided by 2/10 in fraction form, and then I can find an equivalent fraction by multiplying the numerator and the denominator both by 10, and this becomes the problem 86 over 2, the equivalent fraction, and I can do that whole number division in my head. Down here, I can do an estimate, so get an approximate value, and I have a hard time dividing by 0.3 and an easier time dividing by 3, so again, I'll move it one place to the right. This strategy works if you move it 2 places to the right, 3 places to the right, as long as you treat both numbers the same. So to make this computation easier in my head, I'm going to think about this as about 126 divided by 3, which is just going to give me 42. If I were to do this on a calculator, it's 42.24 and more digits there, so not a bad estimate. Finally, the most complicated one is going to be where I try to find the range of answers that this will fall between. My strategy in this case is probably not for beginners. You've got to think about it a little bit, but as you get better, you can do this in your head. So here I'm thinking about the fraction form, and I want to bound this between two values such that the one on the right is larger, is greater, and the one on the left is less. So how do I make a fraction bigger? Well, in the numerator, I'm going to increase the numerator. So if we think about this with some easier fractions, 1/2 versus 2/2, the larger one has the larger numerator. So I'm going to make this 150. I could pick any number I want, but I'm trying to pick numbers that I might have an easy time working with. In the denominator, I'm going to decrease the denominator. Why? Well, let's look at 1/2 versus 1/3. The fraction with the smaller denominator ends up being the larger fraction. So here I'm going to want to have a smaller denominator. In this case, I could reduce 19.75 in any way I want, but to make it easy in my head, I'm going to do 15, because 150 divided by 15 is just 10. I'm going to have my exact answer here, and I'm going to do the reverse on the left. So now I want to decrease the numerator, right? If I come back over here, the smaller numerator is the smaller fraction, so let's make this 140, and I want to increase the denominator. The larger the denominator, the smaller the fraction here. So if I go back here, the larger denominator was the smaller fraction. So I'll make 19 75/100 up to 20. That gives me 7. So my exact answer should fall between 7 and 10. If I do this on a calculator to check, my exact answer ends up being 7.23, and then I get some more digits. So indeed, it does fall between those two values.